All right, everybody. It looks like we're going to go ahead and get started. Welcome, everybody. My name is Sue. I'm a program assistant here at the Elmhurst Public Library. I have turned on the closed captioning. If you would like to turn that off, you're going to find that information either in more or on, you might see something that says live transcript with a little caret symbol on your Zoom menu. This is a webinar format, so we can see and hear us, but we cannot see or hear you. So if you do have any questions, please go ahead and type them into the chat or into the Q&A. I'm going to launch a poll right now that you will see on your screen. It's asking how many people are watching on your device. If you wouldn't mind answering that question, that would be great. The program is being recorded this evening. Probably in a couple of days, if anybody who is registered for the program will receive an email with the link to the YouTube video where you can find this. And really quickly, I would like to let you know about a program that's happening next week. Historical performer Terrence Lynch will be presenting a program as Neil Armstrong and will recount the first moon landing. In the chat right now, I do have links to where you can find information about both the in-person and virtual. If you would like to register for that, go ahead and click that link and you can register online. All right, so hold on one second. Sorry, we're having a couple questions about the live transcript. If you find either more, you're going to find it in more and it says hide subtitles, or in the live transcript option, it shows, and if you click the little caret symbol, it'll either say show subtitle or hide subtitle, and you can click and toggle that and either to turn them on or off. All right, and I would like to tell you a little bit more about our presenter this evening. Excuse me, Professor Sirvatka is nationally known as having developed the most comprehensive community college meteorology program in the country that includes the Next Generation Weather Lab, one of the most widely used professional websites in the nation. Sirvatka is a pioneer in developing courses in storm chasing, which are open for students and the public. Welcome.
Thank you. It's good to be here. I wish I was with everybody in person, but it's nice to be at least here virtually. It's a nice day today. It got a little bit cooler with that lake breeze that came through, but it is March, so we are officially in meteorological spring, which makes me very happy. So I'm going to be talking today about a lot of the stuff that's coming up with severe weather, because we're getting into that season, but we'll also be talking about some other interesting weather events. So if you have any questions, feel free to ask during the talk or save them till the end, and we will have plenty of time for Q&A. So let me tell you a little bit about College of DuPage Meteorology. It is the most comprehensive community college meteorology program in the nation. We have a number of courses from intro to meteorology, which is really what most colleges might have. Maybe some have this severe and unusual, or University of Illinois calls it severe and hazardous weather, but we go way beyond that with 4 classes in forecasting. We have intermediate meteorology, mesoscale, which is more in-depth. These are the higher advanced course. We have severe weather analysis. We do have thunderstorm lab, which is our storm chasing. We do courses on climate and global change. And then one of our newest ones is hazardous weather and preparedness, which is great for anybody who might be into emergency management or something along those lines. We also have the home of what we call Next Lab, which was actually kind of a joke title we named for our program. The new radars that were put in the country in the 1990s was called NextRad. And I just one day kind of referred to our webpage as Next Lab, and that's stuck, and now it's pretty well known. Just to give you some idea of what we do, This is one of the most used professional weather websites in the nation. This is our satellite page. So a few years ago, the NOAA, National Organization of Atmospheric Administration, along with NASA, launched some new satellites called GOES. And there's basically two GOES satellites for the United States. One of them is centered out in the Atlantic. It's called GOES East. And there's another one that's centered a little bit further to the west called GOES West. That one had some problems in its launch, and it actually had some cooling problems. So it would mess up with some of the information, and some of the sensors were not working properly. So just today, I just watched the launch on television. They launched the new GOES West, which will be operational in a couple of months. So that was kind of an exciting thing in my world today. So if we take a look at some of our new users of NextLab, we do have NOAA, we have a number of universities, Environment Canada, professional airlines, just a number, everybody, US Navy, first responders, emergency management, military. We have a number of people who use us because it's just easier to use our web page than it is to use some of the proprietary software. On average, and this is from a little while ago, we haven't looked lately, but we're something at about 38,000 unique visitors every day with over 10 million data hits. And we're putting out almost a terabyte of data just outbound every day. And that's probably going up as we have more and more users on our site. And some of our big days, it's even more than that. So, one thing that'd be kind of interesting is I was just talking to a Hollywood screenplay writer, and there is a movie called Supercell, which will be coming out later this year in the fall. I don't know if it'll be in theaters or if it'll be on Netflix or something along those lines. But this stars Alec Baldwin before the Rust incident and Annie Heche, and that will be featuring the College of DuPage weather site as part of this Storm Chasers arsenal of information. So you can look for NextLab in a Hollywood movie coming up this fall. So I wanted to go through a couple of things to start with, just to talk about what we call billion-dollar weather and climate disasters. So in 2019, you'll see the weather that really impacts, and for the most part, it's in the central US. Now, in this year, we had a couple of tropical storms or hurricanes, a number of tornado outbreaks through the plains, the central United States, and along the south called Dixie Alley. And that's going to be an area we're going to talk about later. There's some flooding areas, get some hailstorms out in Colorado. This one didn't have much winter disaster. It did have some fires out in California and Alaska. And then we shift to 2022, and we see more of the same, a little bit more active of a hurricane season, especially of those hitting the United States. We also had a number of tornadoes and severe weather. So we had what they call a derecho, which we're going to talk about later on, very strong winds. We had some drought, and of course, in the West, you get your fires. We go to 2021. This is a new image that just came out. We see a number of wildfires out there, which is interesting because we started the year with California flooding. And that's kind of an odd thing to think about, is that our fires are often in the wettest years. It is always dry in the Western United States in the end of summer. But if we start out with a wet January, February, March, we get a lot of plant growth. And when those plants eventually die in the summer, as they do every year, fires become a little bit more widespread. Again, a number of areas in the Midwest, severe weather, tornadoes, a couple of hurricanes along the Gulf Coast. This one had that ice storm, if you remember, back into Texas, had a lot of power outages. So every once in a while, you'll get a $1 billion snow disaster. But for the most part, our weather disasters are going to be flooding, they're going to be hurricanes, they're going to be severe weather, and they're going to be fires. So we're going to start out looking at some of those threats in the United States. And we'll start out with everyone's favorite, the tornadoes. So we average in the United States over 1,200 tornadoes a year. And I'll give you some statistics coming up on that. The idea is, if you look at this map of tornado tracks from, I believe this is from the 1950s to the 2000s, there's really no place in the United States that's completely void of tornadoes. Most of them are going to be east of the Rockies, but we do have a number of tornadoes in the Valley of California. We get them along the West Coast. Now, this area here, we don't see a lot of tornadoes showing up on the map, but it's a wide open area, and there's probably more tornadoes than are being reported. But you come east of the Rockies, and now we have almost everywhere is influenced by significant tornadoes. A little bit of a gap in the Appalachians, maybe in some of the higher forested regions, probably more a result of the lack of observations. We often think of this area in the middle United States, the area from some South Dakota, let's say, down in through Kansas, Oklahoma, Texas, Nebraska, as being Tornado Alley. But clearly there's a very high risk of tornadoes down here, which we call Dixie Alley. And we're in that season where the South is really the first area that's going to be kind of bombarded with significant severe events and tornadoes. So if I look at frequency, here is all tornadoes. The center is sort of over Oklahoma. So you think about Oklahoma or Kansas, those dusty big farm tornadoes. That is certainly true. When we look at deadly tornadoes, that area of maximum impact is shifted a little bit to the east and definitely along the south. I want to point out something that Illinois near Bloomington and then Illinois, Indiana with deadly tornadoes is a pretty sizably hot spot in the United States. If we look at significant tornadoes, and we'll talk about how we rank those in terms of what's called the Fujita scale, the significant, the strong and violent tornadoes, the primary region is here in Arkansas, parts of northern Mississippi and Alabama, in through Tennessee and maybe up into Kentucky. So that's really where some of your strongest tornadoes, and those are going to be in what we would call the cool season. So February, March, we can have a number of significant outbreaks. Now over here, we talk about fatalities, and where's the most dangerous place in terms of fatalities? It's going to be mobile homes. And that really shouldn't surprise anyone because the most significant and deadly tornadoes are going to be in the South. And in the South, there's a number of people who live in the prefab houses, right? These aren't trailers per se. They're not carrying their house on their truck. This is just those houses that are on cement slabs. And because they're not well connected to the foundation, you tend to get some pretty significant damage to the houses. And that's why you have a lot of fatalities. In addition, the Dixie Alley area here is going to be full of trees, and the storms that come in February, March, very often are going to be in the evening and early overnight hours where people are going to bed, and it's dark, they can't see the tornadoes coming. When you're out in Kansas or Texas, you look out there, you can see your dog running away for 2 straight days. But when you're in Mississippi with all those trees, you go half a block from your house, you can't see anything through the dense forest. There's still a number of people who are killed in permanent houses because they're vulnerable. If the tornado is strong enough, they're going to do significant damage. And then the vehicle is their number 3 most significant place. So this is from 2021, and it went through the date. So I'm not sure if this one shows. Now this goes the entire year. And we were looking at only somewhere around 1170. So some of the years that we put on here going back another, the minimum that came through was 944. And this axis shows you this calendar days. So we see the number of tornadoes really start to ramp up in March and April, May and June. That's our tornado season. Although we continue with the number of tornado outbreaks all through the year. Now this year, which was, it doesn't say what year this was. I believe this was 2019, had a strong January outbreak of tornadoes where there was a number of tornadoes. And then we had a very active year. So if you look at the maximum that we've had in the last, let's say 20 years, we've had up to 1,884. So last year was actually a little bit below average. Now, interesting thing is we look at some of those years, a couple of years ago, where we had 10 people died in the United States in the year 2018. And that was a record low. We average somewhere around 75 to 85 deaths a year if we look at just most of these tornadoes. But then you'll get a year like this in 2011, where 553 people died. Does anybody know what really the most deadly tornado of that year was? You could write it in your chat box before I tell you the answer. It was a really, really massive tornado and went right through a city of over 50, 60,000 people. That one was in Joplin, Missouri. And so I think almost 500 people died in that one tornado. It's a tragic event. So every once in a while, we'll get an outlier where something major hits. It hits a populated area and the death toll goes very high. But for the most part, we're looking at somewhere between 30 to 100 and some people die annually because of tornadoes. Now, if we go to Illinois, kind of focus on what we're doing here, you'll see a pretty wide variety of number of tornadoes that we will get. This is through 2017 from 1950. But we'll have some years where 100 tornadoes and some years where we get very few tornadoes. Now, if we look kind of at a climatology, this is something a little bit different. I want you to see, you might look at this and say, well, gosh, this looks like we're getting more tornadoes now than we used to. And that's not a true statement. We aren't really doing that. And we can find that and kind of prove it by looking at those significant tornadoes, the Fujita scale. They go from 0 to 5. 0 and 1 tornadoes are called weak tornadoes. So we see a lot of tornado reports, but when we look at the strong tornadoes, F2 and F3, or violent tornadoes, F4, F5, we really don't see an increase in tornadoes at all. In fact, from the 1950s and the 1970s, we're actually seeing a decrease in Illinois tornadoes. So what's the reason that there's more total tornadoes? And the answer is there's more people out there, and there's more chasers, and there's more spotters. And the movie Twister came out, and more people are identifying and seeing tornadoes and making reports. Chasing has become a huge blooming thing from the 1990s. When I started, hardly anybody was out there. You go there now, you might have 3,000 or 4,000 people on one storm. When we look at the number of days in the United States with tornadoes, you'll actually see a decrease from 1991 to 2010. So the number of tornado days is gone down slightly. Now, tornado destruction, I'm sure you've all seen pictures of it with multimedia, social media. You're going to see huge amounts of damaged pictures and all that kind of thing. So we've got just some pictures here of cities where trees are snapped in half. Some of the bark is denuded, just total devastation. Aluminum siding wrapped on trees, just the tragedies. It's amazing. Here's one with some school buses. A very dangerous place to be would be a school bus. Now, I want to show you this. This one doesn't have any audio to it, but it's kind of an interesting picture. There's a security camera on a house. And, well, just watch what happens when this thing plays itself out. So you'll start to see the wind pick up, and then it'll get a little bit darker. So the tornado is drawing. Now the winds have changed direction. Some lightning there, things are flying through the air, and the flow over the house has become so strong that you are going to actually weaken the roof until it lifts up and everything gets sucked into the tornado and everything blows away. So that kind of destruction is why we say don't open windows. Now I'm going to show you one more video, and this is one in Manitoba up in Canada. This is their strongest, LE Manitoba. This is an F5, the violent tornadoes. And I'll let you listen to it, but I'll stop it and show you something. Okay, that right here is a house. So the entire house has been destroyed. Now, The winds in a tornado can go to 200 miles an hour. And what makes them so much more destructive, especially in a short time than a hurricane, is that a hurricane winds are sustained and almost continuously horizontal winds. But a tornado has not only that strong horizontal winds, it actually is drawing air upward. And what that does is it creates a very significant upward force. So I'm going to let this go a little bit further. And over here, this vehicle, I don't know, what is that, 150 feet in the air? This is a minivan full of drywall, very heavy stuff. And it's got so much upward force that it's actually flying through the air. And when we talk about people dying in vehicles, this is one of the reasons. Now, keep in mind, the flight's not really that dangerous, but the landing is where everything becomes extraordinarily dangerous. So just an amazing amount of debris swirling about this tornado. Okay, now closer to home, Fairdale, which is out in northern Illinois, on April 19th, 2015. I'm going to show you this video. It's a pretty amazing video. I'm surprised that the video is what happened. You can read a little bit about this. Clem Schultz, his wife and his next door neighbor did die. So let's see, am I starting this movie? Oh no. I guess I don't get movie controls. So we might just have to wait till the movie starts. So this was an early day, and he's up in his house, and he's looking out his second floor window, watching this tornado. Now, I want you to notice that the tornado gets bigger, but it doesn't move from left to right, and that's always a bad sign. The sound is him breathing. That's all you hear. I don't know what he's thinking, but it's bad. It's hearing some thunder. He's seeing this large tornado. This is an EF4 tornado, so this is violent. It's close to where it is, to the maximum level. And he's watching this tornado come to his house. Now, the rule of thumb is in tornado safety is to get to the lowest floor of the most interior room. Stay away from windows. But Clem is fascinated by the tornado, so he stays up on the second floor looking out the window. Now, meanwhile, his wife is in the kitchen and she's trying to be as safe as she can. Looking at this tornado, you can see the swirling getting more. There's material being drawn in here. And now I'll just sit here and listen. All you hear him is breathing a little harder. And that was the end of the house. Now, as I said, he survived. He was actually knocked out and was able to survive. And obviously the videotape survived. His wife did pass away. One of his neighbors also died and he survived despite that. But it's an amazing experience of what it's like in the tornado. And keep in mind that sometimes when you see the funnel cloud, that is not just the tornado. The tornado's winds actually extend well beyond that. So you could see things flying up, being ripped apart as these winds became probably about 150, 170 miles an hour. Now, this is interesting event. I'm sure many of you know this from last year, June 20th. It was the Naperville Willow Springs, and this was an EF3 tornado. This is a strong tornado. So we're looking at this. There was a tornado. This is the one up in Naperville and Willow Springs that was actually detected as a debris signature on radar. And then there was another one further to the south toward Plainfield, Romeoville. The big one of interest was the one that came across Naperville, and it went through Woodridge. This is Route 75, did a lot of damage, and then it kind of drifted just a little bit south of east. The path length was 17.6 miles. There were no fatalities, which is remarkable. 11 people were injured with a third of a mile wide event. So that was our big tornado event close to home. Now, this map shows how many days are thunderstorm days. And if we're looking at some of these colors here, the state of most thunderstorm activity is going to be Florida. It's being in that peninsula in the summertime, they're going to get a lot of thunderstorms. And it's ironic because you know what the motto of Florida is? It's the sunshine state. We could easily have called it the thunderstorm state, and that would have been true also. Lots of storms out in the Rockies. If you've been out to Denver or hiking, you want to be careful of that region because in the afternoon, every day, you're going to get thunderstorms. Now, for us here in Illinois, we're somewhere in the 40 to 50 thunderstorm days per year. I don't know about you, but I don't think we had many thunderstorms last year, and I was deprived of that because I love thunderstorms. And I think we're actually gonna get some thunderstorms Saturday night. That's the forecast right now. So I'm hoping so. So lightning becomes our other major detraction. This is the killer of people. So over this 20-some year period, we've got 104 people who have died in Illinois, making it in the top 20. The number one state, obviously, is Florida, and I think that should make sense. Although we have a number, New York, Pennsylvania, Ohio, very high numbers, Texas, Colorado with your thunderstorms. But notice that people have died in all states due to lightning. Well, I shouldn't say that. Alaska and Hawaii, at least according to this, they did not. And we do have a lightning detection network, and that's this VISALA's lightning detection network, and we see where the most lightning is. So kind of on the cusp, but get a lot less as you go north and more as we go further to the south. And that sort of mimics the Tornado Alley, the Dixie Alley. But the Gulf Coast in the summertime with afternoon thunderstorms from sea breezes gets you a lot of thunderstorms. Now, flash flooding. This is another important thing. Flash flooding is the most common type of natural disaster in the world. About 40% of all natural disasters are associated with flooding. It kills way, way too many people. It's the leading cause of weather-related deaths in the United States, flooding. People are amazed and they don't realize how significant, how destructive water can be. So a lot of times they drive into flowing water, and that's just a bad idea. So we lose about 200 people a year in flood events. In the 10-year period from 1988 to 1997, we had about $3.7 billion of damage from flooding. And certainly as costs go up and we build more and more and the population goes up, we're going to see those costs going up. About 15% of flood-related drownings are vehicle-related. Your car is not meant to be in water. It's not meant to be in water, especially if the water's moving. Because moving water will make your car buoyant. Moving water can flip it over. I've seen people have died in 2 feet of water inside their car when they get trapped and can't get out. So the big motto is turn around, don't drown. Now, when we go into flash flooding, which is usually associated with thunderstorms or maybe some ice jams, we've had some of that this spring, we get some of the river floods. Now, I don't know if anybody remembers April of 2013, but this is a multi-sensor analysis of where rainfall fell. And this areas in purple were over 8 inches. but almost the entire northern half of Illinois received 8 inches of rain. Sometimes we get those with thunderstorms and they're localized areas of flooding, but this flooded the entire area. And so the Illinois River, a couple days later, after the event, kicked up into a record high flood of 28.8 inches, or 28 feet above flood stage. So this was really bad. I don't know if anybody had any property on the Illinois River. This was an amazing flooding event because we had so much rainfall. Now, other things that we want to deal with would be hail. So this is, again, a 10-year period about how many hail days there are. And the hail areas that are most abundant are going to be out in Colorado and into Nebraska, maybe up here into Wyoming and South Dakota. Although we have 6 to 8 days a year where we're getting hailstorms. Look at the losses. Crop losses are 1.3 billion. Property losses are a billion. So weather alone, just from hail, is $2.3 billion of damage. Now, we usually like to use size of stones. We start with quarter size hail, which is about 1 inch in diameter, and that's considered severe. But we get golf ball, which is 1 3/4 inch diameter, and here's baseball at 2 3/4, and this is an amazing hailstone falling from the sky at about going updraft of 81, coming down, it's probably around 110 miles an hour. So that's a sizable fastball made of ice striking people's heads. So this can lead to some significant impacts. This is just baseball hail. I've seen grapefruit and softball hail, even the size of 8 inches. That's an amazingly big hailstone. Now we have these windstorms, which is another thing going on. And the windstorms themselves is going to be called a derecho. The derecho is actually a Spanish word that means straight ahead, as opposed to tornado, which means to twist. So we get these storms. In this case, it's moving from west to east. Somebody asked me, why is the east-west movement important? Part of the idea of any storm is that most of our weather systems are going to travel from the west to the east based on the jet stream. Now, sometimes they'll move from the southwest to northeast. Sometimes they'll move from the northwest to the southeast. But basically, 98% of all systems and big storms are going to move west to east. And a lot of times you're bringing down momentum from the fast moving winds aloft down to the ground, and you get widespread windstorms. So this is an island full of trees, and almost every tree was knocked down, what we call a pack wash storm. So these derechos we've been getting a number of derechos the last couple of years. This is what they may look like with this shelf cloud. You see a cloud like this. This is not really tornadoes, but you are looking at potentially strong winds. Here's an example of one that hits, and some of you might remember this one. This was, what year was this? 2017. It was on a Sunday morning, because I remember I was out looking at this storm, and it started right out here where I'm at, which is in Glen Ellen, and started to do some damage. And by the time it got through Lombard into Elmhurst, it did some significant damage. But this line of storms continued through the early afternoon, all the way by 8 p.m. into West Virginia. It actually ended up in the ocean overnight. So this is a long-lived, damaging windstorm. There were millions of people without power, hundreds of millions of dollars of damage. Just an amazing event. Oh, here we go. I'm sorry. June 29th, 2012. I knew that I usually put it up there on there. So that was a big one. It went 450 miles in 6 hours with an average speed of 75 miles an hour. So an amazing event. Now, August 10th, 2020, we had an even bigger event. This was big. It produced a tornado. It produced a tornado over in Wheaton, a small spin up there. It also produced another more significant tornado in Lombard, right on St. Charles Road. And it moved almost all the way into Elmhurst. And then it was just a line of strong damaging winds. In Iowa, you had winds that were about 110 miles an hour. It's one of the strongest derechos I've ever seen. So huge complex of thunderstorms that rips across. So these are all radar images over the course of time. They also had 11 tornadoes, so very, very strong winds. Now, another big event was the Missouri duck boat accident, which, I don't have the date on this one. Oh yeah, July 19th, 2018. What's interesting is they had these duck boats that flipped, a lot of people died, and the captain said, well, I see the line of thunderstorms on radar. So this is kind of what it looked like. And they're like, I can make it back to the shore before those thunderstorms hit. But the problem is, do you see this little white line here? That is actually the outflow of this line of storms, or where the damaging winds begin. So it's in this damaging line here, which was about 15 to 20 miles from where it was actually raining. That's where the winds hit. And that flipped these boats, and 11, 12 people died on that. If we look at how many days there's major thunderstorm winds, you'll see that in Northern Illinois, we have a pretty high concentration of these big wind events. Not as much as we are as we go into the Piedmont of the Carolinas. If we look at an area close by in Jackson, Kentucky, you'll see that rather than that March, April, May, June tornado peak, our wind events tend to be more from the late spring through summer. So we might maximize in June and July. And that's true around here. Some of our biggest wind events have been the July or August derechos. So we are a little bit shift away from that. Now, generally speaking, what are our days like here? Well, lo and behold, guess what? We're going into the windiest time of the year, which is March and April. Now, it's not so bad when those winds are really strong and they're bringing in 70-degree temperatures. But when those winds shift out of the northwest and start bringing down those 30-degree temperatures, this is when March in Chicago can be brutal. The average wind speeds will die out as we go into July and August, and then they'll pick up again in November. And so our winter weather tends to be windier. Now, another hazard that we can talk about is snow. Obviously, I don't know if any of you out there are snow aficionados. The older I get, the less I like them. I'd rather forecast snow than actually be in it. Although I will say, I really enjoyed the two events we've had this year because I'd rather be right than be in the snow. So we had a really good forecast. I do the weather for College DuPage, and we were saying 6 to 8 inches of snow were going to fall, and COD closed down. But I guess a lot of the area schools kept it open during that afternoon. It was a real problem. So what was it, a week and a half ago, 2 weeks ago, we had another event, and I told my people, I said, we'll be fine tomorrow. And all the schools closed down early, and then it went, I think it was from the overnight to 3:30 in the afternoon, there was 0 snow on the ground. And schools had shut down because of that. And I don't know. Got to know how to forecast the weather. In any event, these are the number of days with at least 1/10 of an inch of snow. So our peak snow season is pretty much here in January, which would make sense. That's the middle of winter. But notice that it's the second half of winter that actually averages some of the more snowy weather. So believe it or not, January, February are going to be much snowier weather than typical November, December. This year was a very dry December, but we had a pretty decent amount of snow at this point. But look at this, March. We still have a number of days over this time frame where we could get snowfall. In fact, we can get snowfall all the way into early April of 1/10 of an inch. Once we get to about April 15th, it's a very rare event that we're going to get measurable snowfall, even though it could happen. But for March, we're definitely going to have that. So don't put away your shovels, at least not yet this year. Other winter hazards would be ice, these big ice storms. Some really interesting events last week. There was thunder ice down in St. Louis, down in the boot heel of Missouri and Arkansas, where they were getting heavy freezing rain. So it was pouring freezing rain, icing the trees with thunder and lightning as that happened. And we see that the east is really where these hazards are most abundant. Now let's just talk a little bit about climate change. We can say, well, hey, let's look at Illinois temperature trends. And we'll see that the average is this purple one. If we look at the trend overall, it's really not much different, maybe a little bit warmer over the last century. So that overall 1 degree change in Illinois is what we would consider to be climate change. But what about precipitation? It's a little bit different. We see a little bit of an increase if we look at our annual precipitation. So you say, whoa, it's getting warmer, it's getting rainier. But it's an interesting thing about this part of climate change. When we look at winter, we are not seeing, we're seeing a flat line on what is normal for winter. We have winters that are really snowy, or precipitaty, if that's the word, and then some winters that are not. So we go up and down. Really, I know people claim to know what they think their childhood was like versus their adult years. But really, we see pretty much an average. Some years are above average, some years are below average. What's interesting is we do see an increase in the summer precipitation. And part of the reason is what we've done with crops within our state. The fact that we put more bushels of corn and soybean per acre of plantings will actually create so much water vapor in the air that we influence the climate because of the way we use our soils and the way we grow our crops. So this isn't carbon dioxide related as much as it is what we do to our crops throughout the corn belt of central Illinois. Now we also have these things called El Nino, which you probably have heard about. We're actually in the opposite, which is called the La Nina. And we try to figure out when we have an El Nino, and you probably have heard of this, Chris Farley, what does that mean for our weather? Well, blue is colder than normal and red is warmer than normal. And it's not easy to figure out what it's going to be. We are not good at predicting any of those influences. So what's going on right now, as of last week, we tend to look in the Pacific region here. This is the Pacific Ocean along the equator. In this El Nino, it's called El Nino 3.4 region. And we're seeing below normal temperatures and cold water off of South America. So we are in a La Nina. And it was a La Nina last year. And I really think that last year and this year are fairly similar in what we get. Fairly mild at the beginning, turns really bad in January and February, and then it persists through March. So if we get warm this week and we get some thunderstorms, enjoy it, but don't count that it's going to finish March that way. If we look at the current state of drought in the country, the West is starting to get droutier. We've got a little bit of dryness across Wisconsin, northern Illinois. That came about from December. But for the most part, the eastern half of the United States is wet. The western half is dry. And that makes sense because our jet stream has been lots of storm and cold weather to the east. And that's what we've got. Sometimes we look at flood risks. This happened last week. And we see where did it rain. So we use multi-radars, multi-sensors to determine how much rain we assume fell. And in a 72-hour period, we're looking at areas of 5 or 7 inches of rain across parts of Tennessee where they did experience flooding. And then they had the ice storm. So this area, very wet. This is the area that we have to start looking at for severe weather. And that will be happening this month as well in Dixie Alley. So we're kind of approaching the end of this. I want to make sure we have some time for some questions. I do want to invite you, if you're interested in going tornado chasing with the College of DuPage, to go to this web link. And that website is going to show you some of the trips that we have. Anybody over the age of 18 can chase with us. We have people from all over the world. This first trip coming up, I've got people from California, from Alberta, from Alaska. On a trip later on, I've got people from Australia, from England, from the South Florida. People from all over come and chase with us. And it's open to anybody 18 years old or older. And we usually have people from 18 to 80 have chased with us. So you're welcome to do that. We have one trip open, and that's in June this year. If you want to contact me or look at our weather website, it should be an S in here, sorry. This is weather.cod.edu, or you can email me at my link But thank you for your time, and I do want to be able to answer any questions that some of you may have on weather.
Absolutely. I do have one already, but if anybody does have any questions, please go ahead and type them into the chat or the Q&A. So the first question that we do have, Paul, is why is the east-west movement important? And that was back when you were still talking about tornadoes. It was kind of near the end of that.
So here, let me do this. Let me get out of this and go into, where do I want to go? I'll open up, well, here, let me show you a live version of our satellite page. So I'm going to go to this one here. So this is currently going on, currently going on right now. And I'm going to go ahead and loop this, and I'll loop it for a longer period of time. And I can speed this up a little bit. And so what we're seeing is that these are where your clouds are across the United States. And it's basically showing well, here, let me get this out for you. I think I can do Epic Pen. All right. So I'm going to go over here, and I can draw on this now. Oops, no, can I? Oh, I don't think I can draw on that. You know why? Because this is only drawing on a different screen. I'm going to do this first, just for a second. I can stop the share. And then I'm going to do a new share screen, and I'll go here. And I can go here, there. And what I've got basically in this region is I have a jet stream that's flowing. Look at this thicker, going in this direction here. So I look at our satellite pages to say this is the flow of the jet stream, and that's really where the main jet stream is. So you notice that the jet is basically traveling from west to east, like that, and it's a little bit of a wave. So you want to think of this as being a wave in the jet stream. Now, sometimes the waves can be a lot more what we call amplified. So if the jet stream were to do this, that would be an amplified wave. Now, what does that mean? This is the bottom part of a wave. That's called the trough. And then the opposite of a trough is this one over here. It's called a ridge. And this is the area of activity that's most abundant. These are where storms are most likely, when I come downwind of the trough. But the other thing to keep in mind is the air north of a jet stream is cold. The air south of a jet stream is warm. So right now, it's very warm across the south, and it's very cold across the northeast. That's where we've got our coldest air. This is where we've got our warm air. Well, what's it like for us? We're in this transition place here. Oops, that's not what I wanted. So we're in this transition. So we got up to 50-something degrees today. Then the winds come over. We get on the other side of a front. The winds come off the lake, and they start bringing cold air at the ground. So we're going to be kind of bouncing around that area. We can get warm. We can get cold. But the jet stream kind of tells me that. In any event, any storm systems that form are going to move with the jet stream from west to east. Let me show you one more interesting thing on a model so we can kind of tell you a little bit about the jet stream. If I look here, this is where the jet stream is. So this is a map of the United States, which I think you can see. Here's Illinois, right over there. And the jet stream is doing this thing. Okay? So watch what happens as we go forward into time, into the future. Notice that there's a shift. Now in the west, there's going to be a trough out here and then a ridge here. So now we start to get into the warm air with much colder air out in Colorado. And this is where our storm systems are going to be in the central United States. So if I look at that, and I can use my model here to look at winter weather, so I can look at precipitation, what it might look like on a radar, we see a big storm system with a lot of rain coming through. So this is Saturday night where I think there might be thunderstorms. There's going to be snow up way to the north, but a lot of rain. And we go a little bit further and we get rain. And then guess what? Look at that. This is Sunday night and it turns cold. We might be looking at not a lot of snowfall, but maybe an inch or two coming in after the warm weekend. So I'm kind of happy. It's going to be warm. Look at the temperatures out here. There's going to be a time where temperatures may be approaching 60 degrees as we go overnight Saturday night into Sunday. So there's some 60s forecast. Very warm. Anytime you got warm, moist air in March, I think thunderstorms. But life gets worse because it turns a lot colder. Here's temperatures that are down back into the 20s by early next week. So we're on the cusp. Very cold out west and kind of warm to the south. And then we get some really cold air in toward the next weekend. In fact, let's show you how much snow is forecast across the United States over the next, let's say 12 days. Lots, if you're a skier and you want to go out to Colorado, you're going to love it. Lots of snow in the mountains. A lot of snow throughout Nebraska into Wisconsin if you're snowmobilers. It's a lot of winter left. Little bits of snow even as far south as Arkansas and Texas. And then there's even more snow coming. So I want you to be aware of this, okay? I'm going to show you one more thing and then I'll answer more questions. Here's the snowfall accumulated for 2 weeks. Here's DuPage County with 4 or 5 inches. But look it up here with maybe 15 to 20 inches. That's not that far away. And you know, we can't forecast that accurately. So don't put away your snow shovels. It's possible that some of that can happen.
Okay, I've got another question for you. What are flatline winds?
I don't know that term, flatline winds. Do you know what the context are? Did I say something like that flattens the trees? Like a derecho or straight line winds, maybe?
You know what? If you want to add a little bit more information,
here, let me show you this. You should have a black screen now. Do you see it?
Yes.
So when I look at a tornado, a tornado is going to look like this. I'm going to draw a tornado that's spirally. So the winds are actually going around in a circle, spinning around. So it's really violent rotation. So if I had a tree over here on this side of the tornado, the tree is going to push away from us. If there was a tree over here on this side, or maybe a lollipop, the tree would tip toward me. So notice the damage will have a tree going in one direction over there and one direction on the other side. But if I have these straight line winds, all the trees, there's tree 1, tree 2, tree 3, all the winds are going the same direction. So all of the trees get knocked down in one direction. So they all lay out, falling into each other like this. And that's what we call a derecho. If it lasts long enough, that's a derecho. And the idea of that derecho is if I want to know, did we get a tornado or are they just straight line winds? I have to go evaluate the damage to find out which direction things are laying. And sometimes it's really hard to see that. So that's a hard thing to do sometimes.
They shared that they experienced straight line winds in Michigan last August.
Yeah, so those straight line winds they're just the damaging winds, but they're all going basically in the same direction. So all of your damage would have been going in the same direction, as opposed to a tornado where you might see things on different sides of the street going in different directions.
Can you explain what area of the country is Dixie Alley?
Sure. Let me, am I still sharing? Yeah, I'm still sharing.
Yes.
So I'll do a quick Dixie Alley tornadoes. So if I do something like this on an image, this is pretty close. I don't know who's your alley, who's your mama. I don't know who that is. I've not really heard that. But this is what we sometimes call Tornado Alley. It's not super scientific what that means. So if I said, what is Tornado Alley? And I go Cannon. This is one of my students who actually helped define Tornado Alley. Well, we're not seeing as well anymore. I could show you the statistics on this. This is not a bad map of the United States, but if it were up to me, I would go blank US map. Let me do this for you guys. That's fine. What I would say is the areas of the strongest tornadoes, you're going to start out with this region here is going to be the common areas of tornadoes, maybe even a little bit further to the south, in early spring, so March into early April. As you go into May, this area of tornado potential is going to expand to about here. When we go into, let's say, late May, now we're really getting into this area here where tornadoes are going to be very likely. So this is going to be your main threat. If we go even later into the year, we can extend that threat even further to the north, maybe something like this. As you go further into the year, you're going to get less tornadoes south, more tornadoes to the north. So overall, I would say that Tornado Alley, this concept that we have of Tornado Alley might be something along this line. And maybe extend it like that. That's Tornado Alley, TA. And then Dixie Alley would be this area, which would be more in this area. So that's Dixie Alley. That's how I would probably define it. Now, and then there's a question here, what channel or weather service is most reliable in your opinion? I think this is a no-brainer. If you want the best forecast, the most accurate forecast, you go with the Chicago's National Weather Service. They're an outstanding office. They've got some of the best forecasters in the country at this office, and their forecasts are awesome. There are certainly a lot of people on TV, right? Some of them do their own stuff. Most of them do their own graphics and rely on the weather service. So I would go with anybody in Chicago is fine. And certainly I know people, Tom Skilling's a friend of mine, and he's quite the weather nerd. So he's a good one to go to. But when it comes to going, what is your forecast for the upcoming few days? The National Weather Service official forecast is what I would do more than anything, much more than even the Weather Channel. And I don't trust apps. They try to give you details and accuracy that don't exist. Which state or area in the US is consistently the most mild weather? Yeah, I mean, if you're going to live in mild, easy conditions, good life, I'd move down here. You don't have that many, you don't have hurricanes, you got drought, heat waves, but this is going to be least amount of thunderstorms. Any place along the Gulf Coast up through here would give you some really nice weather if you don't like winter. Florida in the deep south gets really humid in the summertime. We get some beautiful weather. I would say live in Illinois in September. I would say live in Kansas in May, live in Texas in March, because that's where all the good stuff is. And go to Florida if you don't like snow, or go to the New England if you like it for Christmas. But as far as threat weather, you can get some big flooding, and even in Las Vegas, in Nevada, you get some big floods. Tornadoes are going to be east fires and strong winds are going to be west. You're going to get hurricanes along the coasts. You know, I like weather that's crazy, so you can't ask me that. The least amount of dangerous weather, I'd probably go to Utah, except for maybe snow. But Utah doesn't have that many dangerous things going on.
Well, we don't have any other questions unless somebody types something in, but I have a question.
Yeah.
Why are thunderstorms more common in the spring and the summer and not so much in the winter? When we hear about a snow thunderstorm, it's kind of like this unique.
Okay, so that's a great question. Really basic concepts. I'll give you as simple an answer as I can in just a couple of minutes. If this is the ground, unstable air, which is what we need for thunderstorms, is when I've got warm and humid air down low and cool and dry air aloft. When I have an atmosphere that the higher up you go, this might be 5 miles up, gets cooler and drier, that's really big. So in the wintertime, what are we missing? In the wintertime, this is what becomes problematic. And certainly the humidity as well. So what you can sometimes do to get thunder snow is you get cool weather here, but very cold here. And that can get you cold enough that the precipitation falls as snowflakes and you get thunder snow. Spring and fall is when you're going to get warm, humid air underneath cooler, dry air. In the summer, this air tends to be warmer and this tends to be more moist. So we lose the ingredients that we need for that kind of weather event. So we can get some thunder snow. That's a fun thing. Doesn't happen maybe once or twice a year. But once we get spring, we get some of those, and you know what it's like. You get that really humid weather. You start going, oh, it smells like the air is moist and your skin's not drying off your scalp and everything, right? It's really nice. And that's when you start to think thunderstorms. And then it'll turn cold and then we'll go to snow and then it'll get warm and humid again. Once we get into May, it's all going to be thunderstorms. And then it's just scattered throughout the summer.
Thank you. That was very interesting. We have one more. What is heat lightning?
No such thing as heat lightning. Okay, so here's the thing about lightning. Lightning is always from a thunderstorm. Now, sometimes the lightning, which is visible from 50, 60, 70 miles away, you can see lightning in the sky, but it's way too far to hear thunder. So what people often will say is, oh, I see lightning. It's really hot and humid. See, there's that warm, humid stuff. And I don't hear thunder, so they call it heat lightning. But it's not lightning because of heat. It's lightning from a thunderstorm, but that thunderstorm is far away. So people call it heat lightning, but it's actually from a distant thunderstorm.
Paul, it looks like, I'm not sure if I'm going to pronounce this word correctly. It's in the Q&A. Is grapple? Grapple an actual term.
Grapple. Okay. So sometimes in the late winter, early spring, you'll get sort of convection, these thunderstorms that are going out, and you get snow pellets. That's what grapple is. So sleet is called ice pellets. And if you ever listen to your car window, you hear tick, 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 tick. That is sleet. But grapple is actually little bits of snow that fall. I describe them looking like Dippin' Dots. They'll bounce a little bit, but they don't click because they're squishy and you can kind of push them. That's called grapple. Whenever you have grapple, it's cold enough to keep it below freezing. The precipitation doesn't melt into a raindrop. But you also have a good chance of getting thunder and lightning if you're getting grapple. So it's not really hail, it's snow pellets. That's what grapple.
Very interesting.
Yeah.
I bet you probably could go on for hours and hours. There's so many
I love
fun
to talk weather. That's
fun facts.
that's why I like, in-person stuff. People like, oh, I have this question about weather.
All right, I think we've got one more here. How does a straight line wind originate? Is it predictable?
Yeah, basically what's going on, and I'll pull up my little blackboard again. What happens is it starts out like this. So here's the ground. Here's the rain falling. So we have rain falling onto the ground. And what that does is it brings.
Okay, Paul,
Wait.
you just share your screen.
I can't share my screen. Hold on, oh no, what I do? I need to share the screen. There we go. Okay, there. So rain is falling on the ground. This is from where the thunderstorm is. So you might see a thundercloud and it will draw the thunderstorm looking something like this, really tall. It starts to precipitate. Well, that air from the rain starts to come down and it's cooled by evaporation. So when the air comes down, what's it going to do when it hits the ground? It's going to spread out. Okay, it's going to go in different directions. Well, in this case, if there was damaging winds, trees, like we talked before, might fall this way. Over here, a tree might fall this way. So it'd be divergence. But if I've got very strong winds, where everything has got that momentum, that carrying the winds from west to east, let's say, what that really says is the winds coming down here are going to be weak, but the winds over here are really strong. So most of the damage is going to go from the west to the east, and that's where your trees are going to get knocked down. So that's your true straight line winds. And these thunderstorms, they can last for hours of time. So you get damaging winds for hundreds of miles. And that's where you really get that derecho event.
Paul, are you okay to answer another question?
Yes.
Do you feel that our storm systems are becoming more severe or intense due to global warming?
No, I do not. I do not think that is happening. In fact, the data is showing almost the reverse of that, that a warmer atmosphere tends to produce less vigorous storm systems. Especially if you want to look at tornadoes and you look at the tornadoes in the United States, we're seeing fewer tornadoes by some amount. If you look at hurricanes, you're seeing fewer hurricanes, even though each one might be slightly like 5% stronger because of a global warmed planet. So when you're looking at storm systems, I wouldn't say that's true. Do you remember when I said the jet stream separates cold air to the north from warm air to the south? That may be less true, less difference in temperature. The less the difference in the temperature, the weaker the winds. The weaker the winds, the less aggressive the storm systems are. So I think global warming is actually causing a little bit of a decrease in some of those significant storms. But I really want to urge you that it's a small percentage on a large scale. So if we're looking at an average of 15 hurricanes and now we're averaging 14.1, it's really not going to find much difference, because the extremes, the years that are above normal and below normal, that variation year to year is way bigger than you will experience with an average number going up. So you, as a human being, without looking at statistics, are not going to know what that experience is like. You're not able to discern global warmed experiences of wind or temperatures. That's a statistical measure. And I think that's something that we should understand.
Great. Thank you so much, Paul. This was very, very interesting. And I know that everybody else that is viewing shares in that opinion. Thank you so much.
Great.
Thank you, everybody, for coming. Remember, this program is recorded, and you will be receiving a link to that YouTube video in just a couple of days. Thanks, everyone, for coming, and everybody have a good night. Thank you, Paul.
Awesome. Thank you. Take care.
Good night, everybody.